Good morning, namaste and warm welcome my dear students, guardians and all the viewers who have been watching us in Kalika TV SD and from its Facebook Live and from YouTube too. I am Prakash Subedi, your mathematics teacher, and I have been teaching for standard 9. So, this time we have been learning geometry, and then what we discussed yesterday, I hope you have remembered. We completed one theorem yesterday about the triangle, the first theorem of standard 9, and theoretically and then practically by paper folding method, by showing some pictures of GeoGebra, I have shown you, and then we just proved one theorem. And what was the theorem? Let us see in the slide what we studied yesterday in our last class. Look at the slide please. Okay. So, this is what we proved yesterday. The sum of interior angles of a triangle is equal to 180 degree. That is the theorem that we have proved yesterday, that the sum of interior angle of a triangle is 180 degree. So, today we are going to read out theorem number 2, that theorem is about an exterior angle of the triangle. So, let me see what we are going to learn. Okay. So, dear student, let me focus you to the board please. So, we are going to prove the exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of its opposite also we can say, but we can also say non-adjacent interior angles. Yesterday also I explained this topic. We are going to prove today the exterior angle of a triangle is equal to the sum of its opposite either opposite or non adjacent, anyone you can write, sum of its opposite interior angles. So, yesterday also I explained about this, and today also we are going to prove the same theorem. So, let me see in the slide, I have made some pictures using GeoGebra, and that picture shows, you can understand a little from that picture as well the fact about this theorem. So, let us see in the slide please. So, dear student, here you can see exterior angle is angle CBD and its non-adjacent interior angles are angle ACB and angle CAB. Non-adjacent interior angles are angle ACB and angle CAB. You can see in the figure, there are two angles in blue colors and one angle is in red color. These pictures I have extracted from GeoGebra. It is a very wonderful app for mathematics. So, you can see there that exterior angle is shown by red color, and you can see the sum in the first figure 116.1 is the exterior angle, and the sum of two interior angle you can measure. One angle is 77.45 and the other angle is 38.66. If you add these both angle, you will get the sum 116.1. I have randomly made a triangle and then I judged the angles there and I got the sum as shown you there in the figure. Second figure also you can see 31.67 and 58.33. They are opposite interior angles to angle beta, that is equal to 90 degree, and you can see if you add those two angle gamma and alpha, or gamma is 31.67 degree, alpha is 58.33 degree, and their sum is 90 degree. Similarly, some more example I have made for you, so that you will understand the fact that what we are going to prove today. Here also you can see, here you see in first figure beta angle, angle B, angle CBD, exterior angle is 148.07 degree, and its opposite to its two opposite interior angles are one gamma is 90 degree and that alpha is 58.07 degree. If you add these two angles, you will get the sum exactly 148.07 degree, that is angle beta. And actually, you know, this is given by GeoGebra software app. You know, randomly I took 3 vertices, I drew a triangle, I made an exterior angle and I got the result like this. You can also check in GeoGebra application. It is a kind of software for mathematics as well. So, look at the last figure. In last figure as well, the gamma is given 23.44 degree and angle C is given 33.53 degree, and their sum is beta, it is red in color, it is 56.98 degree. In this way, I have just shown you 4 different triangles and the relation between exterior angle to its opposite interior angle, or you can say they are non-adjacent interior angle. So, we can see this in PIP please, and then here I am going to focus you the same theorem in the board. Okay, you can see in PIP it is you know that what we got from GeoGebra, and now we are going to prove it theoretically. One more important thing, let me tell you, dear student, as shown there in the PIP, you know, you can make that triangle and you can cut it, and then if you cut that red part, red angles, 2 angles, and then if you paste it at the place of that beta angle, then it will be completely covered by that cut piece of angle A and angle C. It means by paper cutting method also you can prove, you can verify this fact, but today now we are going to prove the same fact, same theorem theoretically. So, let us see here, prove that, we need to prove it theoretically. The exterior angle of a triangle is equal to the sum of its opposite interior angles. So, theoretically what we are going to show, that I have already told you. As there in the figure in PIP, sum of 2 blue angles is same as that red angle. Sum of 2 blue angles in last figure, it is also same as that red angle. So, let me make similar figure. Okay, here I am making the figure. So, this is A, B, C, D. ABC is a triangle, and you see this is exterior angle. When side AB is produced to D, exterior angle CBD is formed, and this one and this one, these 2 angles are interior angle opposite to angle CBD. So, if we need to prove it theoretically in geometry, you know, we must start from what is given. So, we write given at first. What is given to us, dear student? This theorem is about triangle. We you know, like we want to prove some fact that is related to a triangle. It means we have a triangle, it is given to us, and one exterior angle is also given to us, and we are going to prove the relation between exterior angle to its non-adjacent interior angle. So, in given we write directly, you can write this way, in triangle ABC, comma, which side is produced, dear student? Normally we write side AB is produced, side BA is not produced. Let us say AB is produced to D, because from B we have produced it to side of B. So, we write in triangle ABC, side AB is produced to D, so that an exterior angle CBD is formed. Now, you can also mention what are its opposite interior angles, but it is not so much compulsion. This is given to us. Obviously, in triangle ABC, there are three interior angles, angle A, angle B, angle C, and this one I have shaded black. This is the exterior angle formed when we produced a side AB up to D. Now, what is to be proved here? Angle CBD is equal to angle CAB plus angle C is the angle, angle CAB plus angle CAB plus ACB, you can write ACB. This is CAB, this is ACB. We need to prove that exterior angle CBD is same as the sum of its opposite interior angles CAB and ACB. Its opposite or its non-adjacent, you can say. This angle B CBD, this angle CBD and this angle, these two angles are adjacent angle. Adjacent angle means two angles are said to be adjacent angles if they have one vertex B is common and one arm is common, BC is common arm. So, these two angles are adjacent angles. So, now we are talking about its non-adjacent angle, and yesterday I told you sometimes we need some additional plan to prove it, and therefore, we make a construct to that help us to prove the fact, but this time we can easily prove this all. You know how? Let me show you. Let us suppose this is alpha A, this is small c, this is small b, and this angle is d. So, simply here I am just going to show you what is the sum of a plus b plus c, dear student. It is 180 degree, because the sum of interior angles of a triangle is 180 degree. And next, if you write b plus d, what is the sum, dear student? 180 degree. B plus d 180 degree and a plus b plus c 180 degree. Both are 180 degree. It means, dear student, we can write a plus b plus c same as b plus d. Can we write? Yes, of course, equating the fact, equal axiom. This is equal axiom, like we discussed about the axiom. We can do, this is known as equating from statement 1 and 2, a plus b plus c, b plus d, both are equal to 180 degree. Therefore, we can say that a plus b plus c should be equal to b plus d. And in algebra, you have already simplified. From both sides, if you remove b, if you subtract b from both sides, what do you get? A plus b plus c minus b, b plus d minus b. If you cut, a plus c will be equal to d. This is what we are going to prove today. Look, this is very easy to prove that exterior angle is equal to its opposite interior angle. Now, we do not need additional construction, dear student. Therefore, I am starting writing proofs. Statement, reasons. At first, dear student, let me write you the sum of three interior angle of a triangle, angle CAB plus angle ABC plus angle ACB is equal to 180 degree. I added all 3 angles of a triangle and I wrote the sum 180 degree, because yesterday we completed this theorem, because the sum of interior angles of a triangle is 180 degree. Number 2. Next I am writing, dear student, look in the figure that I have named B here, that B angle is, can you name B angle, dear student? Angle ABC plus angle, let us write CBD is equal to 180 degree. It is because they are linear pair of angle. Now, let me tell you what is known as linear pair of angles. Look, these 2 angles are just adjacent angle. These 2 angles are not linear pair of angles, because let us suppose this angle is 30 degree and this may be 41 degree. What is the sum of these 2 angles? 71 degree. So, these 2 angles are not the example of linear pair. Linear pair of angles means those angles that 2 angles in a straight line and their sum, the sum of their measurement of the angles is 180 degree. It means, look here, this is rough part I have made. Look, this is 65 degree, this is 115 degree. What is the sum, dear student? So, such 2 angles, so here this is 180 degree, okay. I think it is not seen well, let me write it again, this is equal to 180 degree. So, 2 adjacent angle are said to be linear pair of angles if their sum is 180 degree. Linear pair of angles means 2 angles, a pair of angles whose sum is 180 degree, they are known as linear pair angles. Or 2 angles, look, this is a straight line, my hand you can take this hand as a straight line, and look 2 angles you can see, this one acute angle, this one obtuse angle. Now, sum of these 2 angles is 180 degree. These are 2 are the angles on a straight line. These 2 angles are angles on a straight line in a linear line, linear equation, a line represented by linear equation. Yes. So, such 2 angles are said to be linear pair of angles, because these 2 angles are made on a straight line, okay, and their sum is 180 degree. Or dear student, instead of writing linear pair of angles, you can also write they form a straight line or they make a straight angle, that can be the reason. Now, number 3, the RHS is 180, the RHS is 180, dear student. So, both left hand side, both of these are equal to 180 and 180. So, we studied a fact as an axiom. For that, let me show you in the slide to remind you some axioms. Please have a look to the slide, please. So, dear student, I have okay, look, I have listed out some axioms that you should remember. Look at equal axiom, dear student. If A is equal to B, A equal 3, then B equal 3, and it means if A is equal to 3 and B is equal to 3, then obviously A should equal to B. It means that. Did you see equal axiom? Okay. Now, equal axiom, you can see the axiom in PIP, please. Okay, you can see that. Yes, you can study those axioms if you can. So, using equal axiom, dear student, 1, 2, 3, sum of these 3 angle 180 degree, sum of these 2 angle 180 degree. So, both left hand side are equal to 180 degree. Therefore, we can write angle CAB plus angle ABC plus angle ACB is equal to angle ABC plus angle CBD. So, what we did here, from statements 1 and 2 using equal axiom. This is equal to 180, this is also equal to 180, it means both of these are equal, this is known as equal axiom. Next, dear student, look, let me underline same thing, ABC is here, ABC is here. If we subtract ABC from both sides, what will be left in left hand side? Angle CAB plus angle ACB will be left, is equal to, okay, wait a minute, CBD, angle CBD. Yes, I hope you have seen it. Yes. Now, look what we did here, we subtracted angle ABC from both sides. This can be done in an equation. It is like if A plus B plus C is equal to C plus D, we can remove this C by subtracting on both sides, then we get the result A plus B equal D, and same fact is used here. We removed angle ABC from both sides, subtracting angle ABC from, okay, from, let me write it here, both sides of statement 3. Look, this way we have proved. Look, what we did here? We subtracted angle CAB and angle ACB. This angle ABC is subtracted from both sides, and we got these two angles in the left hand side and angle CBD in right hand side. So, I hope you have understood this fact as well. This is the second theorem. You have started learning theorem. Okay, learning geometry is very interesting, and I hope in the beginning you may feel like something interesting and something difficult as well, but actually geometry is the easiest part in mathematics. It is not difficult, it is fantastic subject. So, you should learn it well. So, before, let me see some that homework in the slide, please. Okay, in PIP it is okay, in PIP you can see, dear student. So, this is the theorem that we have done, and look, I have given some figures here. So, by using the property of sum of interior angles of a triangle, find the interior angles of the following polygons. You can see 1, 2, 3 polygons are there, and then you need to find the sum of interior angles using the concept of first theorem. So, this is your homework just to practice, and thank you so much for being with me till now. Tomorrow, now next Sunday at the same time I will come.